So almost your first unit is completed, and so we will do the revision today. Is it okay? So it's better to recall everything from starting onwards. And if you're having any queries, you can ask in this session. So that's why I made a revision today. So if you respond, so shall we revise the
Okay,
first?
sir. Okay, sir.
So what is your first topic? First topic of this unit? What is your first topic?
Semiconductor devices.
Semiconductor device. That is your unit name. Under the unit first unit, what is your first topic?
Types of semiconductors.
Types of. The first topic is PN junction diode, right?
Diode.
I just given an introduction starting.
Forward bias, reverse bias.
The first topic is PN junction diode. So I will project the screen. Is the PPT is visible? Hello?
Yes, sir.
Visible. Okay. So this is first topic, so PN junction diode. So you know what is a PN junction diode? So two types of semiconductors are there. One is P type, another is N type. So P is having holes, majority holes, and N is having majority electrons. So electron is negative charge, and holes are positive charge. And we see now you can able to see that, right? I'm changing the slide. Is it visible for you?
Yes, sir.
Yes, sir. Okay. So now what you are seeing in your screen?
Forward bias, reverse
So
bias, PN junction diode.
symbol of your PN junction diode, and forward and reverse bias. So forward bias means I want to give more magnitude when compared to your more magnitude to the anode when compared to the cathode, then it represents forward bias. And if I'm giving more magnitude to the cathode when compared to the anode, that is your reverse bias condition. And you know that PN junction diode allows the current flow in one direction. Okay, so this is just how they are making the P and N types and all, or we will go to that forward bias directly. Okay, so during the forward bias, what I'm going to do, I'm giving the positive, so it represents more magnitude to the anode and negative, less magnitude to the cathode. So due to this potential difference, so this more magnitude, positive magnitude, will try to push the holes towards the junction. So center one is there, right? So that is a junction. And we already seen that while forming the junction, so previously we are connecting P type and N type and putting together, right? While putting together, the electrons and holes, the free electrons and holes nearby the junction will recombine and create a small depletion layer. Okay, and so here you can able to see, so this is your junction and small depletion layer will be there. So here the electrons and holes are recombined, so it becomes immobile ions, so there is no free electrons around the junction, across the junction. Okay, so after giving the forward bias, the holes are trying to push towards the junction. Similarly from here, the cathode, I'm giving the negative, so the electron is pushing towards the junction. So what is happening, it is trying to cross the junction. Once you are giving a particular cut-in voltage, so cut-in voltage is the minimum required voltage to push the electrons to cross the junction. And for a silicon it is 0.6, for a germanium it is 0.3. Always keep it, remember. Okay, after giving that voltage, the conduction will start. Okay. So after pushing it, what is happening now inside the depletion layer? I am getting the free electrons, so it represents depletion layer is becomes reduced. So it is also called as a depletion layer or a space charge region. So once you are giving more, you can able to see once I'm giving the more amplitude. So now what is happening? It is crossing the junction, so that the current flow will occur. So this is the main. So this is how. So thing is, small layer of depletion layer will be there. After giving the forward bias, it becomes 0. Okay, so that the electrons start to flow due to high mobility. So this current is called as a diff current. Okay, and if we go to the reverse bias, so in a reverse bias condition, I will change the polarity. So in the second, I am just replacing, changing the polarity of the magnitude. So anode I will give less magnitude and cathode I will give more magnitude. It represents cathode I am giving positive, anode I am giving negative. So due to this, the free electrons, listen, it's moving. Yeah. So now the depletion layer, so now the depletion layer in this level only. Okay, from here to here, a small one. So after giving the negative to that anode and the positive to the cathode, it is trying to attract. So here I'm giving positive, right? So here it is n type. So n type having positive. So n type I'm connecting to positive, and n having majority of electrons. So electron is negatively charged. So positive and negative will try to attract. So due to attraction, the electron is moving away from the junction. So once it is moving away from the junction, so here also there won't be any free electrons. So here it becomes immobile ion. Ions won't move. So there is no free electron, means there is no electron to cross or move. So it is immobile. Okay, so that the depletion layer become higher. So that is what here representing. So once you're connecting, it is moving away. So that what will happen? The depletion layer is keep on increasing. So that it will act as an insulator. So there is no conduction. So there is no current flow. And breakdown is nothing but by giving a more voltage. So it is a very less voltage, limited. So breakdown is nothing but I am giving 20 voltage, 30 voltage, means on the time the conduction will occur. So that is nothing but the breakdown. And we seen the two types of breakdown, avalanche breakdown and Zener breakdown. So what is the difference? So how it is getting the energy? So in a reverse bias condition in avalanche, by giving the excess field, so I'm giving the more voltage, 20 voltage, right? So the electron which is immobile getting the sufficient energy to come out of that bond, so that covalent bond. So that's why we are able to create the lot of free electrons after giving high voltage. So always the breakdown will occur at high voltage. Okay, and we see in the VI characteristics. So during the forward, so during the forward, first initially, if I am giving less than cut-in voltage, current will be very less. Once I am giving the more cut-in voltage, I am crossing the cut-in voltage, the current is increasing drastically. So this is what they are representing using the animation. So once it is a cut-in voltage, once it is crossed, it is increasing the movement of the electron. You can able to see it's more. So it represents current is more. Okay. Similarly, in negative region. So in a reverse bias condition, I'm going to represent in both reverse bias voltage negative, current also negative. So up to this, it is very less amount of current, and in a positive, the current will be in the range of milliamps, but in the negative, it will be in microamps. So you can able to see here I am representing microamps IR. So you can able to see here IR is in microamps, but in a forward bias always it will be in milliamps. You can able to know that LEDs are using, right? We are using LED, light emitting diode. It works under 330 volt, 330 milliamps. So that is the current rating. So diode also will be in terms of milliamps. In reverse bias, the diode, LED won't glow. It represents that no current flow. Similarly here, the diode also in reverse bias condition, there is no current flow. Once it is crossing the breakdown voltage, after that the current flow starts. Okay, so that is what represented. So this is your basic operation of your PN junction diode. And now we will see the Zener diode. Any queries in PN junction? Any queries, guys?
No, sir.
No. Okay. So now Zener is visible. Zener diode presentation.
Yes, sir. Xenodiode name is there, sir, but any circuit diagram is not there, sir.
I just okay. So now, what you are seeing?
Introduction anode cathode.
What you are seeing? Is it visible?
Yes,
I
sir.
am showing.
Xenodiode.
Huh?
Yes, sir. Visible, sir.
Okay.
Xenodiode symbol.
Okay. So here I'm showing the Zener diode symbol. Always keep on remember the symbol. It's very must. So if they're asking any explain about the PN junction or explain about the Zener diode, so first you have to give the definition. Okay. After that you have to draw the symbol. So symbol is very much important. And after that the construction. Whether if they ask construction means you have to explain about the construction, or simply they are asking about the working principle. So working principle means the forward and then reverse. Those are nothing but your working principle. Sometimes they will ask explain the formation of PN junction. So formation means how what kind of type of semiconductor they're using and how they are attaching. After attaching, how the depletion layer are forming. So these things you have to explain. In some other cases they will ask characteristics of Zener diode. So you have to explain about the characteristics based upon the mark. If they draw ask the characteristics for 3 or 4 marks, you can able to draw the waveform and then just a small explanation. If they're asking 10 mark means you have to write about the forward and reverse bias condition and the characteristics. Okay. So here we are looking the Zener diode symbol. And what is the difference between PN junction and Zener diode is PN junction is lightly doped and Zener is heavily doped. Okay. And Zener diode can operate in breakdown region only. So we are not going to use in forward. Why? Because PN itself will work in the forward. Zener specially it is designed to work in the reverse breakdown region. And what is the application of PN junction diode? Rectifier. And what is the application of a Zener diode? It's a regulator. Okay, regulates the output voltage. It will provide the constant voltage. So I will show. And so it's a PN junction diode with heavily, so heavily doped, and it will work under the reverse bias condition. Okay. And yeah, so this is the Zener. So operation will be same in will be like a forward bias condition of your PN junction diode. Only reverse, after occurring the breakdown, it will, I mean the depletion layer becomes reduced. Okay. And we've seen what is the difference between the reverse breakdown and which is occurring in the Zener, as well as the breakdown which is occurring in the PN junction. So PN junction diode is represent avalanche breakdown, and Zener representing Zener breakdown. Okay. So here the same they are trying. So initially very less depletion layer. So after increasing the voltage, is it okay? It's free electrons and okay. Here they drawn in reverse manner. So this is your P and this is your N actually. So this is your N and this is your P. So that's why now it is in forward condition. Okay, so N is having holes represent in blue color, so that is a free holes, sorry, free electrons, and the holes in black color. And this is like sufficient kinetic energy they are getting after I'm giving them more voltage. So after that only this will come out of this covalent band. I told you, right, from each and every band, so it will come out. So after it is coming out, it will try to hit and make the other free electrons. So thing is, it's getting sufficient kinetic energy and coming out of the bond, and after that free electrons having the kinetic energy, right, so still it will bombard with, it will collide with another compound. So after that hitting it, it will make the another electrons to come out from the bond. So that's why a huge number of electrons are coming and again hitting the another free electrons. So you can able to see. So initially, listen. So initially, so only one came. Okay, after that this one and hitting the next one. Yeah, so it is hitting the next one. So after hitting it, it will make this to come out. So here you may get already one free electrons and it is hitting that and making the another one, right? So I may get two electrons and here it becomes a hole. Okay, so this is how generating the multiple free electrons inside the depletion layer. Okay, so that is nothing but a breakdown. And if you go to another breakdown, so this is Zener they are explaining. So Zener having a depletion layer which having more immobile ions. Why? Because having a huge um, what do you call concentration, so impurities. So that's why they are drawing more. Okay, and if you able to see the Zener breakdown occurring, so due to high electric field, it is coming out. So which is gaining the electric field in avalanche due to the kinetic energy, but here in Zener due to the high electric field I am giving, it is coming out. That's it. After that it is not bombarding. So that is the difference. Okay, and characteristics are similar. Only thing is in a reverse you may get a sharp edge. Actually it won't be in this curve. It won't be like the slope. Actually it will be like a straight line for a Zener. Allah. So this is how it will. So in a forward, it is act as a p-n junction diode. In reverse, the reverse breakdown voltage. So here it will stop at, suppose if it is breakdown is 5 volt means 5 volt, 8 volt means 8, 20 means 20. So based upon the rating of your diode. Okay. So that's why they will use in that regulate purpose. So regulate means providing the constant DC voltage like your charger. Okay. So in your charger they are having, surely they will have the p-n junction diode for rectification and Zener for regulation. Okay, any queries? And Tina, guys, any queries?
No, sir.
Okay. So next is half wave and full wave rectifier. So what is half wave rectifier? Now you people talk. What is an half wave rectifier and full wave rectifier? How it is working? What is an half wave and full wave rectifier? What is an half wave and full wave rectifier?
So in which the current flows to the load resistance in one direction.
So current flows through the load in one direction. So half wave rectifier, actually rectifier is a circuit used to convert the AC to your pulsating DC. Okay,
DC.
so pulsating DC is nothing but like you may get a waveform, but in only one amplitude level. So DC means if it is 5 means it will be in straight line. So it will be in positive means positive, negative means negative. Okay, so here half wave rectifier means just taking the off of your waveform. So sinusoidal means alternating current having the positive and negative. Half wave rectifier take only the positive, otherwise it will take only the negative. Okay, so it won't take positive and negative both. Why? Because we are using only one diode not to convert it. So one diode means only one direction the current flow will occur. If I'm using the two diode in reverse direction, so I will change the polarity. On the time you may get both the waveform. So that is called a full wave rectifier. So here I don't have everything. So here only one diodes are available. I'm giving the sinusoidal waveform like this, and in a half-wave rectifier, the setup will be like this. The setup is giving the AC supply to 30 volt, and I want to reduce the voltage level, so I'm just reducing it and using the step down transformer. After that, I'm connecting the diode here, and this is your load. Okay, so load is nothing but the output where I'm going to get the output. So once I'm giving input waveform as a sinusoidal, so during positive, here the anode will be in positive and the cathode will be in ground manner. Okay, so due to that one, higher amplitude I am giving to the anode, it will start to conduct. So what are the input I am giving, the same output I will get like this. So I'm getting one off cycle, and next while I'm giving the negative waveform, it won't conduct, so it will be in reverse bias condition, and the amplitude level is very less, so that breakdown won't occur. Okay, so due to that, there is no current flow in negative. So again, when it is coming to positive, it is allowing to pass the current, so that I may get the waveform as well as I may get the waveform for the current as well as the voltage. Okay, so negative cycle is totally suppressed. And of a rectifier, so same they're explaining. And frequency, output frequency will be equal to your input frequency, and in full wave rectifier I'm using the two diode alternatively. So one diode for a positive cycle and another diode for negative cycle, and for this I'm specially using the center tapped transformer, so that it will change. So during the forward bias, the D1 will conduct, so I may get the waveform, and during the negative bias, the D2 will conduct. So conduction will occur in this direction. Okay, you can able to see here. Initially, if it is coming from this rotation distance, for negative cycle, it will be coming from in this rotation. So center tap is nothing but grounded. If you see the center tap transformer, here it will be A will be in plus 12 volt, means B will be in minus 12 volt, and the center one will be a 0. So totally 3 voltage I'm getting. So one is a positive and this negative, and another is ground. So 3 voltage level.
Sir, in
So
bottom, which direction it will flow, sir? In B2?
so in bottom, the arrow mark representing, right? So it will flow in this direction. So from B, it will go to the diode, and after that, it will go to this plus of your RL, and then to your minus of your RL. And similarly here also, it will be like this. And you can able to see, and from A, it is coming. For during the positive, it will be from A to D1. Okay, and here I am giving the negative voltage. I told that. So A is plus 12, means B will be in minus 12. Okay, so due to minus here, it will be I wait a second, I will draw this. It's not available. Pen I'm not able to make. Okay, pen option is not available. Okay, listen. I will explain. During the positive, here A will be in positive. Okay, and the anode will be in positive, and here the cathode of the D1 will be in less amplitude level, so that the diode D1 will conduct. And during the negative, so listen, first during the positive, A will be in higher and B will be in negative. Okay, so I'm giving the positive signal of your input, but I told center tap having 3 voltage. A will be in plus 12, means B will be in minus 12, and center one is nothing but 0. Okay, so if I'm giving the positive voltage, now A will be in positive and B will be in negative. Okay, so due to that, anode of D1 so is positive, and anode of the D2 is nothing but negative. Okay. On the time, D1 will conduct. Why? Because the anode, which is having higher polarity, that will make the conduction. So D1 will conduct. Okay. Now I'm giving the negative signal. Once I'm giving the negative signal, now A will become negative and B will become positive. Why? Because I told it having three magnitudes. One is positive, another is negative, another is ground. If I'm giving positive means A will be positive and B will be in. I'm applying the minus signal, so it represents minus of your amplitude level. If it is 12 means 12 volt. And now I am giving the negative signal. So negative signal representing minus 12. So minus 12 I am giving means A is positive terminal. So positive with negative voltage, it will be negative. And B, I told it is a negative terminal, and I am giving the input signal negative waveform. So negative negative it become positive. Is it right or not? Is it right, guys?
Yes, sir.
Yeah. So here now while giving the negative voltage due to the negative polarity B, negative negative become positive. So on the time D2 will conduct. That's why the current flow will be from B to D2 and towards the positive of RL. If you see that RL, the waveform, the current flow in same direction. Is it right? Whether you are giving a positive also, the arrow mark will from plus to minus. If I'm giving negative also, the arrow mark will become plus to minus. That's why you are getting all the signal at positive itself. So here you can able to see the output voltage. Output you can able to see it will be like this, always positive. Why? Because here due to changing in polarity and changing in the polarity of your input signal, it become positive. So due to will conduct, so current flow is occurring. Okay, so this is your full wave rectifier using 2 diode, and a bridge rectifier I am using the 4 diode. So during the positive of cycle, while I'm giving the positive cycle, here it will be positive and here it will be less magnitude level. So 5 0, otherwise are 12 0. So it representing D2 will conduct, and similarly which is available quite parallel to that, D3 will conduct. Why? Because here cathode is connected to less voltage. Okay, so that the current flow will occur from plus D2 and it will move to here and it will move to in this direction and come to here. And in a negative cycle, I am giving here the negative voltage, and here it becomes a 0. Here it will be negative. So that what will happen, the D4 will conduct, and which is available parallel, D1 will conduct. So the current flow will become from minus to D2 and 2 in this direction, and it will go to the D1 and towards your positive. Okay, so from this voltage to this voltage. Listen, I told during the negative this will become higher negative magnitude level, and this will become a less magnitude level. So the current flow will occur from here and again passing through plus to minus. So that's why whether it is in positive, it will be come from in this direction plus to minus to the load. If I'm giving negative also, the output current flow will be become plus to minus. So that's why everything is coming on same in output. If you see, everything coming at the positive. So that's why you are getting everything. I mean they will used to tell suppress the negative and become in positive all. So this is your pulsating DC. You can see what is the advantage and disadvantages and all. Okay, so any queries in rectifier? Actually it's the easiest topic. Any queries? Guys?
No, sir.
Okay, so next we will discuss about SAR silicon controlled rectifier, which is having a 4 layer. So 4 layers of your different semiconductor. So here 3 terminal with 4 layers. So 3 terminal is anode, cathode and gate. So gate is used to make the flow of current from anode to cathode. Okay, and if you see the structure, it will be P1 N1, P2 and N2. And so model, they given transistor model. Next unit, the first chapter is transistor. We will study about that, so that you can able to easily understand how the transistor will function. Okay, so the operation is quite simple, and So here what I am doing in the sense, in SCR you want to give higher potential to your anode and lower potential to the cathode, and the positive trigger to the gate, then only the SCR will fire. So fire, otherwise I will tell it's on. SCR is on condition. Okay, so if first condition I am not giving any voltage, no voltage, so I'm not giving any voltage to the gate initially. After that I am giving the positive to your the P and negative to your N, so that the junction J1 will be in forward as well as the J3 will be in forward bias. So what about here? So here the J2 will not conduct. Why? Because it will block the current flow from the J1 junction to your J3 junction. So it will be in a reverse bias condition. So once I am giving positive voltage to the gate on the time only, it start to do the conduction, so that the conduction will occur from anode to your cathode. Okay. The characteristics, so initially I'm not providing any voltage, so that very less current is occurring due to minority charge carriers. Okay, so once I'm giving listen, there will be a two operation, one is without gate and with the gate. So without gate, and you know it is having the reverse bias condition, right? Suppose if I'm giving a more voltage, so reverse breakdown will occur. So without giving a gate, here I am giving a gate voltage, so that I don't want to exceed the breakover voltage. So exceed in the sense, for anode and cathode, if I'm giving 20 volt and the reverse breakdown of the semiconductor is 20 volt, means by giving more voltage, I mean more than 20 voltage, I can able to make the current flow without any gate. And otherwise if I want to make it normal function, in the sense I will give a less voltage, so that if I'm giving 2 volt or 3 volt to you to here, the conduction will occur from anode to cathode with the help of a small gate voltage. Okay, so that is what mentioning here. The characteristics is slowly it is coming like this, and if I'm giving the breakover voltage, it becomes I mean resistance becomes negative, and so that the voltage become less, the current flow become higher. And if you can able to see here, they drawn another diagram, dotted lines with the gate having less voltage. So if I'm giving less voltage, less number of the conduction will occur at, for example, voltages 3. Suppose I am increasing more gate voltage, means the conduction will occur at 2. So here represent 2, here representing 3, so that you can able to see that here they are given with different gate current. So gate current representing the gate voltage. So how much voltage I am giving, based upon that current will increase. So if current is increasing, surely the conduction will occur with less gate voltage. And if you see that reverse blocking region, so if I'm giving the change the polarity, it won't conduct. So once the breakdown is occurring, so in negative, if I'm giving more voltage that is equal to your breakdown, the avalanche effect will occur, so that the conduction will occur. Okay, but mostly we will prefer to walk in the forward direction. Any queries about SCR? Any queries?
Okay.
And diac and track, any doubt is there? Diac and track, any doubt? Any queries? Any doubt in diac and track? Why? Because recently only we seen. Guys, I am talking to you. It's not a one-way communication. Hello, can you able to hear?
Yes, sir.
Yeah, any queries in DAC and TRAC? It's a discussion session, ma'am. So we have to revise it.
No, sir.
No. It's okay. So what is the difference between DAC and TRAC then? If there is no queries instance, I hope that you people are understand the concept. So what is the difference? What is the difference? Anyone? Guys, all of you attending the classes or still you are just available? You're not listening. I don't know. The response is very less. It's okay. Okay, how many of you are completed the task which I given, the homework which I given last week? And I created a Google Classroom and posted the same, not to made the provision to upload your answer scripts. How many of you completed? I'm expecting all should contribute in that one. But in the classroom itself, very few members are joined in the class. Not full strength. So 23 students has to be in that classroom. Yeah, Nitish and Arun Kumar, you completed?
Yes, sir. Submitted, sir.
Submitted. So far I got Anantu Madhav, Ashwin and who is that Ghost Rider? Change your name. I want to know your name. And Madhuban, Nitish, Uday Kumar, I received. Arun Kumar, I didn't receive. Did you?
Sir, my camo. I have
Mycam?
submitted in my.
Oh, the provision is available in Mycam.
Yes, sir. I take photo and submitted, sir.
You take photo and submitted. Okay. So only thing is you can able to upload an image or you can able to upload any PDF file.
Only photos, sir.
Sir.
Sir, it's mentioned that you have to submit in PDF, sir.
Come again. Who is that? Nitisha.
Yes, sir. It's mentioned that it should be in PDF form, sir, in Google Classroom.
Yeah. Google Classroom I think support only PDF.
Yes, sir.
Okay. Any. I required you to complete it. That is my. Whether you
Yes, sir.
understand.
Have sent in form of PDF only, sir.
Okay. So Mycam is supporting only JPEG and. Did you try it in website? I mean, using browser, the MyCamo?
Sir,
Yeah. Did you? I mean, the other people's. Because some people told that it's very difficult to upload in MyCamo.
Sir, PDF is not uploading, sir.
Sir.
Only photo is
you
uploading,
have to
sir.
save in Drive, sir. You have to save in Drive and then upload, sir.
Where in Camo or
No, sir.
Google Classroom.
Google
Yeah,
Stay?
yes, sir.
Okay. And class representative Uday.
Yes, sir.
I think very few are available in classroom. Google
Yes,
Class.
sir. Some more. Somebody have not joined this Google Classroom, sir. I don't know what their problem.
I will point out.
I already posted the message in the group, sir.
Yeah. So
But
Nitish available and Abhinav both are not available it seems. Unmute your mic. Abhinav, yes, and we join in the classroom and I think she also she has shared the class ID in order to join it. So install the app and then yeah.
Abhinav,
Yes, sir.
So I can't able to point out everyone. So those who are not available, just join in the classroom and complete the task which I assigned. Okay, it's a simple task.